Okay, so in this problem, i-apply natin yung work equation para malaman natin yung amount of work done by the applied force. So let's take a look at diagram A. So this is 1A. So the applied force amounts to 100 newtons. 15 kilogram daw, but we won't be using that in this problem. O, tingnan mo kung saan, sa description, kung saan siya nag-displace. So, horizontal displacement, total of 5 meters. So, this is your displacement, if you would draw the arrow. So, using the formula F d cosine theta, work is force 100 Newton times displacement, which is 5 meters, times cosine. What's the angle between the force and this displacement? No, we don't have any angle of separation. Cosine 0 is 1. So, 100 times 5, 500 joules, diba? Newton times meter. So, the work done by the applied force, you will say it like that. The work done by the applied force on the object is 500 joules. Okay? Okay. Okay, let's take a look at this one. O, yan. Diagonal yung force mo, di ba? The next thing that you have to find out is saan siya nagdi-display. So, it's getting displaced horizontally. So, this is actually the angle. If we put the displacement vector here, the angle between them is actually the 30 degrees. So, work, force, displacement, cosine theta. Work, again, you put 100 newtons. Okay? Pero diagonal, yun ay diagonal force. What you want to get is the horizontal component of that force. Kasi yung horizontal component ang magkakos ng horizontal displacement. That's why you have a cosine 30 here. So what's the displacement? 5 ulit. Times 5 meters. So 500 joules. What's cosine 30? Let me input that. Cosine 30 is... Okay, 0.8660. So let's multiply that by 500 joules. We get 433.01 joules. That's the work applied by that's the work done by the applied force. Oh, ito naman. An upward force is applied to lift a 15 kilogram object to a height of 5 meters. Okay, malito, baka magsabi kayo dito ng 0. Akala nyo normal force to, but this is applied force. Minove niya naman pataas yung object. So, the displacement now is up towards, up, diba? This is your displacement. So, by the same logic, ng horizontal displacement, wala pa ring angle of separation, diba? Between the force and displacement. So, this is actually cosine 0. The force is, it's not given. But the displacement is 5 meters. How do I find out about the force? Ano yung consider ko? O di ba para mabuhat ko yung isang bagay, kailangan mapantayan ko or mahigitan ko yung kanyang gravitational force kasi yun yung humihila sa kanya pababa. So actually, I have to compute for the FG. That's mass times acceleration due to gravity, 15 kilogram times 9.8. That's G, di ba? Cosine 0 is 1. So what's 15 times 9.8? 15 times 9.8, 147 Newton times 5. Oh, let's multiply 147 by 5. I will get 735 joules. Okay? Okay, those are illustration problems. How about number 2? So, di ba sabi ko sa inyo kanina, hindi lang naman isang force ang nag-act sa isang diba? Sa isang body, sa isang object. There are multiple forces. Like in the case of this illustration, there are 3: normal force, gravitational force, and applied force. So pag binigyan ka ng FBD, alamin mo agad kung saan nag-displace yung object. Sabi dito, to the right. Kasi if you know, may eliminate mo yung ibang forces. Kasi sila ay perpendicular to the displacement. Normal force, displacement, 90 degrees. So you know that this is 0 work. It's not doing work on the object. gravity and displacement is also 90 degrees. There's an angle, 90-degree angle between them. So this is also zero work. So, what force is doing work on the object? Only applied force. Yun lang yung kukumpitin ko. So, work, F applied, D cosine theta. Work, F applied is 10 Newton. Displacement is 5 meters again. Cosine between F and D is 0. 50 joules. Because cosine 0 is 1. Okay. Let's do more. Now you're given with frictional force. Kung sa bike, tumigil ka ng pagpedal, so wala kang applied force. You're pressing the brake. So you have frictional force with a magnitude of 10 newtons. So, syempre, pag nagpipreno ka, di ba? Lalo na pag mabilis, di ka naman agad-agad titigil, di ba? So, while you are pressing the brakes, the bike was able to still move for 5 meters. Let's say na padaos-os ka. Kaya hindi ka agad basta-basta nakatigil. So again, you're still displacing, di ba? Displacing to the right. This is perpendicular. Normal force, gravitational force is perpendicular. So I don't expect you to still be solving for that. Ibig sabihin nun, zero work ang binibigay nila. But right here, there's an angle of separation, 180 degrees, di ba? So, FD cosine theta, 180 degrees. F and D. 10 newtons, 5 meters, cosine 180. Cosine 180 is negative 1. This is 50 joules. So the brake is doing negative work on the bike. The brake and bike, that's their relationship. Okay, how about this? Now you have both applied force and frictional force. So again, saan siya nagdi-displace? You have to know that. To the right. So, rightward displacement. Again, perpendicular ang normal force and gravitational force, they're doing zero work. Let's solve for applied force first. So, work by applied force. D cosine theta, 10 newtons. Displacement of 5. Cosine of 0. Cosine 0. So, 10 times 5 is 50 joules. Cosine 0 is 1. 50 joules. Work done by the applied force. Positive siya, di ba? Positive work. How about the work done by the frictional force? (10 newtons, 5 meters, cosine 180 degrees, di ba? So, dahil rightward yung displacement, opposite side, opposite direction. So, 180 degrees. 50 joules times negative 1, negative 50 joules. That's the work done by the frictional force. Okay, this is the last one. Okay, the only problem that you will have is the angle. So dito daw, si Ben is carrying a suitcase. So, this is the stairs. So, nandito siya. Nandito yung suitcase. This is the original position. The suitcase is may weight na 200 newton. So, ibig sabihin, kailangan niya magbigay ng applied force na upwards para mabuhat yung suitcase. Kailangan magbigay siya ng applied force na 200 newton or diba? Or more. Let's say 200 newton, minimum. The height of the stairs is 10 meters. So, syempre, at the top of the stairs, hihilahin niya yung suitcase para nasa nasa hallway na siya if he is in a hotel. So, kapag hinila niyo yung suitcase, maglalagay naman siya ng horizontal force doon sa suitcase. Okay? 50 newtons yung halaga nun. And, kailangan niyang gawin yon over a distance of 35 meters. The displacement should be 35 meters. So, definitely, you can see here that there are two processes na ginawa si Ben. Kineri niya pataas ng stairs at saka hinila niya horizontally yung suitcase. So, meron siyang upward displacement, saka meron siyang horizontal displacement, yung suitcase. So, how much work daw ang ginawa ni Ben doon sa suitcase during the entire motion? When I say entire motion, diba, divided into two kasi. Yung naging motion. Up the stairs and along the hallway. Let's solve first doon sa ginawa mong work by carrying the suitcase above doon sa stairs. So, you have to put applied force, diba? Para mabuhat mo yung suitcase. And then, you will be displaced. Ano yung displacement mo? Horizontal ba o vertical? Cosine theta, angle between force and displacement. So, the work done when you were carrying the suitcase over the stairs. So, I told you, dapat mapantayan mo yung gravitational force o yung weight ng suitcase. So, the applied force that you should give or apply on the suitcase is 200 newtons. What's my displacement? What's my initial position? What's my final position? That's another way of asking. My initial position is right here. My final position is right here. The initial and the final position is separated by 10 meters. Dapat tumaas ako, diba? So, I have to have a vertical displacement. Equal yon sa height ng stairs, which is 10 meters. So, another way of looking at it is I applied 200 Newton upward force to cause an upward displacement, the suitcase. So, upward force, upward displacement, there's no angle between them, cosine 0. So, the work done habang nasa stairs ako ay 2,000 joules. How about, nandito na ako sa red dot, sa hallway. Di ba, hinila ko siya? So, what will happen? What's my work done when I pull the suitcase? So, again, I apply the force, displacement, and cosine theta. So, yung aking force na 50 newtons, kailangan mag-cause siya ng 35 meters sa displacement. Siguro that's the distance from the stairs to your hotel room. So, this is a rightward force and this is a rightward displacement. So, therefore, the cosine or the angle between them is 0. So, cosine 0, that's 1. So, definitely, I'm just multiplying 50 and 35. So, what's 50 plus 35? No. Why did I say plus? Times. 50 times 35. 1750. 1750 joules. Okay. That's my work done on the stairs, on the suitcase. I have to add it to get the total work done. So 2000 plus 1750 is 3750 joules. Okay? Okay. So I believe that's all for this module. Thank you, and I'll see you next week.